Okay, so let's start stripping this motor down. So that's the control box, that's off. And that's where the motor wires go, underneath there. Yeah, so quite an interesting construction, I think. So where it's got the coils, the sort of wound stator, so you can see the stator around the outside there, and then you can actually see the rotor coils there. There's a little, I've got a bit more light on now, so you can see that rotor position sensor a little bit easier. That's quite cool, that ring, that lobed oval ring that rotates in there, quite interesting. I always love it when I see this. So there's 5 holes for this rotor position sensor, but it's only got 3 screws in it. The early ones actually had 5 screws in. Bit of Renault process improvement, and those ones aren't even tapped, so you can't even get some spare ones and put them in there. But it's only absolutely crucial and critical for the function of the vehicle that there's no movement in this. So Renault just yeah, didn't bother with those 2. But yeah, Renault for the win. So yeah, so it's if you spin it quickly, you can kind of hear it's not too good there. So this is the wiring, so got to take that off. You've got to get this sensor off as well. So start stripping this down. So this is where you've got the brushes are in here. Should we just take that off? One moment, please. Let's just strip that off. So we can show you in here. That's the wrong thing. I'll be back in a moment. Okay, there we are. So got this brush box cover off. So at this end, we've got, these are the phase wires. Well, this is actually the neutral, I believe, on that end. Yep. So that's the negative. So it's like a kind of star configuration, I think it's called. So these windings are all connected to like a kind of central point, and then that central point is connected to this neutral. It's an interesting configuration, because if you look up wiring for 3-phase motors, you get 3 wires. They kind of look like that, and if they've got magnets, they don't have that either. So you kind of just have 3 wires. You might have a position sensor, obviously that's at the other end. So why has it got all this extra stuff? So it's got a center point, which isn't actually required for the motor to move. That's actually because of the chameleon charging system that they have on these Zoes. So basically these are your phase windings. You can kind of go between any of the phases to make it move however it wants to fire it. But in terms of actually the chameleon charging on the Zoe, so the Zoe charging is quite complicated. It doesn't have a single onboard charger like other EVs. It actually uses the motor coils for boost conversion. So when it takes in AC, and all Zoes can do 22 kilowatt AC, and it doesn't have an onboard charger with big coils to do voltage boost conversion, it uses the motor windings. And it basically needs that neutral point to be able to access the parts it needs to do that boost conversion for charging. If you get a chance to look up the chameleon charging system on the Zoes, it is actually quite fascinating. So it's using the motor controller, so like the transistor block in the motor controller, to fire the motor coils and use the coils in the motor for boost conversion, instead of having to have an onboard charger with coils. And basically to do 22 kilowatt AC, you'd need a load of big coils, and you've got some sat there. But to do that, you also need to be able to make the motor not move, because obviously if you put power in the motor coils, if it had a magnets on the rotor, so permanently magnetized rotor, the motor would move. So when you plugged it into charge, the cord would move, which would be a bit problematic. So they have a wound rotor. So this is the end of the rotor shaft, coils around the rotor that end here, so just like a single coil effectively around the whole rotor, hence you've just got 2. And then these are the what are called the excitation wires. So basically the motor has to be excited. So these get kind of like just a little tickle of current. You can kind of see from the thickness of the wires, they're not going to get a lot, just to make them magnetic. So that's just a single coil around the rotor, and these are the real power ones that are pushing against that, or kind of making the rotor push itself round effectively. And these are obviously a lot smaller, because the stator is all the way around the outside, whereas the rotor coils are just in the middle. So interesting stuff. Anyway, this is a temperature sensors, if you're wondering what that is. And so this is the brush box. So to get power onto that rotor, it's got copper slip rings and carbon brushes. So people often get a bit excited when they find out the Zoe's got carbon brushes. Oh, it's a DC brush motor. Is it the 1980s? No, calm down. It's a 3-phase AC motor. It just happens to not have any magnets, so no rare earth magnets and stuff. Yeah, so just lots of copper. So I haven't taken these off yet just to show, so we can see we've got quite a bit of brush carbon material sat in there, but kind of consistent with the mileage of the vehicle. Those slip rings look okay. There's a little bit of wear on those, so a bit of a lip on there. I've seen these really bad, and one I didn't rebuild was because they were really bad, but that looks okay. Let's just get a good shot down there. Yeah, they're still nice and central, those. Tiny little bit of a lip that I can feel, but not too bad there. So I think I'm so far happy to rebuild this motor, happy to carry on. I mean, yeah, as I said, it hasn't broken down, but you know, something could be marginal, and this is a long job and we want the car to be reliable. So it'll be interesting to see how much wear these brushes have got, considering it's done 116,000. But yeah, they need changing, because the control box fits here. You can only access these when you're in this condition, basically, and everything's, you know, when the car looks like this, and the control box is over here. And obviously, so if you later had a problem, if you had a problem with these brushes in 6 months, yeah, it'd be a bit stupid not to obviously replace them now. Those brushes are about £100 from Renault, so not vastly expensive. And yeah, need doing, but yeah, all of this needs cleaning up. These brushes need taking off, so I'm just going to get them off and we'll see how much wear they've got. So that'll be interesting after 116,000. All right, I'll just get those off. Okay, so we've got these brushes off, so you can see there there's quite a bit still on. I've got a new set actually. Well, actually I haven't got any new sets, but this is the lowest mileage set I've got that came off a really low mileage damaged motor. Yeah, so you can see there kind of where they get to. I think effectively, annoyingly, these are a slightly different design. When you, so these are the original brushes. If you go and order them, they're brown. I don't know why they're brown, but they're brown on all the ZE40 motors, and then when you order them as replacement for sort of ZE22 or ZE50, they're brown as well. But they are the correct ones, and they sort of go up to about that lip, so slightly sort of a quarter of the way into this edge piece. And you can see there, so interestingly, one's got a bit more wear than the other. Maybe that they sit at a slight angle. But yeah, that front one, I mean, are they all the way out? Yeah, I think they're kind of all the way out of there. Hard to see. Oh, that one is sitting in there slightly. It doesn't seem to want to come out. But yeah, that one's slightly in there. So that back one, let's say that when it's new, it's sort of, yeah, slightly higher than that one. So there's still quite a lot of material left on there, isn't there? I mean, that's, what would you call that? I'd say there's a 80% still there, something like that. I mean, 116,000, these are designed for the life of the motor. I mean, I could put these back. I think it'd be a little bit foolish, wouldn't it? Probably. I mean, these are off a used motor, so I bought a motor stack and the motor was damaged basically, so just stripped any useful parts, and yeah, these can be reused. But you kind of think these could as well. I mean, there's still quite a lot on there. Be a bit cheap, wouldn't it? I mean, yeah, really, at least we need to put these on or put some new ones on. But yeah, I mean, it just goes to show those brushes could do, I mean, they should be able to do far more than it's done, 116,000. So yeah, they'd be good for quite a while, to be honest. So yeah, just thought that was interesting. This is a brush kit, comes with a little plastic cover, so when you get them there, sort of push down, and then this goes over them, so that you can push that over and take off the plastic, and they kind of pop out, and it just stops basically the brushes from catching on these rings as they go on, because they are carbon, they are quite soft. But yeah, interesting. So I hope that's useful. So next jobs, so I've taken this cover off, which is that one that's laying across there, because these brush wires basically wiggle through this hole and then out through here, and then they're held on by that plastic cap. So you get that off to take the brushes off, and obviously you need that off as well to get the cap off. So this end is kind of ready. I've got to get this wiring off, get the sensor off the other end, and then we can actually crack this motor open and replace the bearings and have a feel of the old bearings. Last one I did, one bearing was far worse than the other one. It's always interesting to see whether there's variance in which bearing's wearing or whether it's one end. It'd be nice to know why it wears out, really, because the bearing should last a lot longer. I mean, like, these carbon brushes are designed to obviously last a really long time. I don't think it's poor bearings, to be honest. I kind of have a feeling that it's sort of an applicability issue, as in the bearings are good, but they're not the perfect fit for this situation. Because at the end of the day, this is like an industrial motor, basically. It should last a long time. So yeah, something like 80 kilowatts, I think, in this variant. Yeah, I mean, realistically, we should be able to make motors that are reliable for a long time. But yeah, it just seems to be a bit of a bearing issue with this one. Whether it's alignment, I don't know. Interesting. Let me know if you've got any thoughts. But yeah, that's what the brushes look like. So that's where it comes as a kit. Those ones are pretty good. That's about where they are brand new, to be honest. Yeah, and these ones, yeah, that worst one's probably, yeah, that worst one's probably 70%. I mean, it is sticking in here a little bit, so yes, what, 70-80% still left on the brushes. So yeah, they'd go for a long time. It's a real shame about the bearings, really, isn't it? Because the rest of it would be all right. But yeah, all right, cool. Catch you later. So I got this motor kind of with everything off. So the rotor position sensor is off there, and then down this end we've got this plastic kind of cover off that holds the wires, brush box cover, brush is off, and we're basically ready to then open it up. So I'll get it popped open and then show you what's what inside. Yeah. These are quite interesting motors in that they're air cooled. That's something I haven't actually mentioned. I talked about sort of different bearings and speeds and things. One of the other things, because they're an air cooled motor, so the reduction gear that's here has like a gap in it, and the fan blows down into it, and that blows through the motor. So there's some cooling holes. Yeah, you can see them around the edge there, around there. So all the way around the stator, there's cooling ducts, and then kind of through the motor as well, you can actually get some cooling, and then that exhausts through that there, and then there's a duct that pushes it down and into the hole in the under tray. So because of the motor being air cooled, you obviously can't use an open bearing, because there's a potential for dust and moisture, because there's no kind of like filter on the cooling air that runs through the motor. It's hard to tell how often the motor actually turns on that cooling, so we don't really know how much air gets blown through the motor. But you want a bearing that's not going to get a lot of sort of be affected by dust and moisture. Basically, we do know, I mean, we get this corrosion. The sensor had a bit of rust on it. Just grab that. So this is the rotor position sensor. So there's a bit of surface rust on there, and also the sort of sensor ring. They're prone to a bit of rust on. This one's actually not too bad. These are cheap to buy, by the way. Put a new one on. Yeah, this one's pretty good actually. But yeah, I've seen these with quite a bit of corrosion on. So we know that they must get moisture in, basically. I mean, it's a big lump of metal. It's outside, obviously, so it's going to get condensation on it. So these are subject to dust, a bit of moisture, condensation, that kind of thing. So you've got to have a bearing that's going to be protected against that. And when you look up the specs, the metal shielded ones are not as good. Well, they're better for high speed. They're not as good at keeping out dust and moisture as the rubber seal ones. So these bearings are a real fine line. That's why choosing a good bearing is tricky, really. You can see it's pretty dusty in there. We'll have a bit of a better look at what they're like when they come out. But yeah, you can see there's quite a bit of dust in this. A bit dark in the light. Yeah, you can see how much dust is built up there. That's the original snap ring. Whether it comes from the factory with those two legs, I don't know, really. Kind of annoying, but yeah, that's got to be released. But yeah, interesting. Yeah, cool. So yeah, I'll get this apart and show you in a bit more detail what it looks like. All right, catch you in a bit. Okay, so we've got the end cap off, so we're getting somewhere. Let's get some light on. So they are a really interesting design, and part of the difficulty of doing these bearings is knowing why they've made certain design choices, because you've obviously got to make choices if you're going to replace these bearings. So this end is particularly bizarre. So this is the bearing that's got the rubber seal. It does spin, but doesn't sound too good. And then it's covered in all this material, but whether that, it kind of looks, it looks coppery, that, but I think that is carbon dust from the brushes. And then the cap, so just inside, so this is the inside of the cap that fits over that shaft. So this is the brush where the brushes go, the slip rings, just cover them up to protect them with some tape. So it's got this sort of spring, like steel spring, okay, kind of weird. And then obviously that carbon dust all collects in there. But yeah, just a really odd design. So why has it got this rubber seal? Why has it got this spring? Is that to push the bearing? But I mean, the bearing is so tight on the shaft, there's no way that can move, you know, in and out. So yeah, just really odd, and it's reasonably tight in here. So yeah, let me know your thoughts, really. So you kind of got to make some assumptions when you're doing this. So obviously I mentioned earlier that if you don't worry about this rubber seal, then you've got more options, and if you look at the bearings, you'll pretty quickly find that out. If you go with this groove with the rubber seal, you're really going to have limited options, but it's entirely up to you. You know, different people are doing it different ways, and yeah, it's difficult to know what's going to be reliable long term, because I don't know of anyone who's actually put serious miles on one of these motors. I've done, you know, reasonable miles on some of the motors I've built, but not, you know, not sort of 50, 60, 70,000. But yeah, we can really see right in, see all the rotor windings there. So this is all the stator. I always think this always looks so rough and ready. There's actually a video, if you search on YouTube, of Zoe motors being built, but yeah, they kind of use these cable ties. You can see snipped off bits of cable tie there. They use cable ties to hold it in place, and then there's sort of string then holds it in. But I really always look really sort of rough and ready kind of thing. But yeah, they obviously work. Just these bearings. So yeah, that one's not too good. Be interesting to see what the other one's like. So yeah, I need to get this rotor out, and then we'll see. All right, cool. Okay, check this out. So we've got the rotor out. So I'm kind of adjusted each time I do it with this, but it's really easy to damage it as you go. So inside the motor, it's got like these kind of like shims almost. They're all lined up metal. Trying to get a good shot of that with the light and the camera, but yeah, hopefully you can see that. Oh, you can kind of see there that they're sort of lined up. And if you look over there, I've separated them slightly. I'm slightly difficult to see because of the light. You might be able to see there, I've sort of pulled them with the rotor. The rotor is really heavy. The whole motor together is probably about 55, 60 kilos. And I reckon that weighs 20 kilos, something like that. Yeah, so you're trying to get that out, but not damage that. So yeah, it's certainly not an easy task, but that is out. So we've got the two bearings still on the rotor here. I kind of vary the way I do it, but interestingly, that one spins freely, but you can probably hear he's making a bit of noise. Hopefully you can hear that, but I can certainly hear it. Just a little bit of noise, quite a lot of play in that as well. A lot of sideways play, and then this is the other side, so the sort of output shaft that goes into the reduction gear. And that one, yeah, is really stiff. It's actually quite notchy as well. If you get to certain points, it kind of like locks up a little bit, and you can see this is aluminium corrosion, sort of corrosion between the aluminium and steel there, and then there's bits of rust on it as well. So yeah, which is all of that's kind of damaging where it's sitting as well, and that's quite bad actually, that bit. So yeah, so I next need to kind of look over it all, clean everything up. All these surfaces all need cleaning up, because as you put it back together, these are going to cause it not to be totally square. But it's out, and that's what it looks like. Hopefully that's interesting. So next job is obviously to replace these bearings. So get these ones off, put the new ones on, clean everything as much as possible, so that everything is sitting correctly and totally square. And because it's spinning so fast, it's absolutely crucial that everything lines up. So sort of all these surfaces, and so where we've got like, so this is the cap that goes on the end, where we've got all of these, you know, everything's got to be cleaned up. And it's got these sort of locating pins, you know, it's all got to be totally as clean as you can be, but without, so, you know, you've got to clean that surface, but you don't want to take anything off that surface. because you need it to sit back exactly how it was. So hopefully that's interesting. That's what the inside of a Zoe motor looks like. So yeah, we can really see those stator windings clearly in there, slid in. Those in between those bits of metal there. Quite a fascinating design, really. Yeah, and that's what the rotor looks like. So it's got these big fat metal parts, and then the windings around there. So yeah, quite cool. But yeah, interesting that that bearing's noisy but spins freely, so it's obviously not totally happy. Yeah, and then this one's really quite rough. I can try and spin that, but it stops itself, and I've kind of moved it a few times, and yeah, it does get kind of stuck in places. So yeah, really not very happy. But both bearings there, which is kind of interesting, so not just one. Yeah, and so next job is to get this all cleaned up, put it back together. Hopefully this one will be all right. If not, I'll have to put another motor on it, but yeah, we shall see how it goes. All right, catch you later. Okay, we are now fully disassembled, so the only way is up from here. So yeah, getting the bearings off the shaft, one of them was really well stuck on. I don't know if it's the sort of ambient temperature, but you'd think that would make the shaft smaller anyway. But yeah, with a sort of bearing puller, 2-foot lever bar, you know, gun on the bearing puller, just yeah, you certainly got to be brave to do this job. I think I was stupid, one of the two. So yeah, so that's the one on the output shaft on the sort of other end of the motor. Yeah, so and then that one, yeah, it doesn't look too pretty, does it? But yeah, that's the one that's sort of quite notchy, yeah, and quite bad. And then the other one's the one that's covered in the or was covered in the kind of brush material, but spins quite nicely, but has got loads of play in it. So yeah, not too good, and it's filthy. Right, so I'm going to get the new bearings, get them on here, get it back together, and then see what we've got. So far, I think this motor will be okay. At least it's just going in a vehicle that I own, so I can drive it around for a bit and just make sure we're all happy before I decide what to do with it. So yeah, all right, cool. So I'm going to get my new bearings and get them on here, and basically get that back in, and then see what we've got. All right, cool. Okay, home straight. So put the new bearings on the shaft, got the shaft in, and then got that circlip back in. These, you can kind of see these circlips are really annoying. I haven't got any legs, even if it's just had a little notch. I'm kind of tempted to Dremel a notch, or I'll try and find some better circlips, I think, because that's a pain in the backside. But yeah, anyway, that one is in. And then on the other side, you can see we've got that one here. So yeah, we're trialing this one. This one's got a little bit more resistance because of it just being that rubber shield, but we shall see. So I've cleaned up all of these surfaces, and similarly around the other side where the bearing sits, because like the old one, that's that one, isn't it? It's got, like, it's pulled the aluminium there, it's sort of deposited rust on, you know, all these things. Ooh, get in focus there. All these things need cleaning up. But you also got to be really careful because it's aluminium. It's quite soft, so if you give it a good, you know, a good scrub with some sandpaper, you're going to take off too much material, and then the bearing is going to be able to move. So it's a real balancing act of cleaning it up, but not actually removing any material to affect how it works. So yeah, fun and games. It's all part of the job. So yeah, I've got that one on there. Basically got this cap all cleaned up. Got this spring back in. So I find this spring really odd. So effectively that's pushing between the case, and it's quite a stiff spring. There is some give, but yeah, I'm pushing against the outer race. But the outer race is held in this case anyway. So it's kind of, it goes on, it's snug, but not mega tight, I would say. If everything's all square, it goes on relatively easily, this cap. And you can just do up the bolts, so that's fine. Just sort of present it up there. The bolts go through and that pulls it on. And you don't have to put a lot of force into that. So it's not mega tight. But yeah, that spring pushes on the outer race there. But why? I mean, on the other end of this shaft is a bearing with a circlip holding it in. So I don't know. Does it just keep the rotor forwards? But yeah, I fail to see how that spring has enough force to push the whole rotor forwards. Very strange. I don't know. Maybe when it's brand new, it keeps things in the correct position. But as I say, it's got a circlip on the other end. It can hardly move anyway. Very strange. If there's a motor design expert out there who can enlighten us, that would be fantastic. Because yeah, a few things are a bit confusing. Similarly with that rubber seal, I mean, what's that sealing? Is that keeping the brush, you know, where we had all that material from the brushes? Is it keeping that out? But then it's basically solid. You know, the bearing is snug in this housing. There's not really a gap, but is that just to make sure that the brush carbon material can't end up in the motor? I don't know. So yeah, let me know what you think. But yeah, so I'm going to get this cap popped on and then just check it spins nicely. Right, catch you in a mo. Okay, so the cap is back on. So I had to clean up all these surfaces because they're a little bit corroded, but that is on and it's all looking good. So let's spin it and see what it sounds like. All right. So there we go. Sounds pretty good. You can just about hear the bearing. You can hear that one. That's the rubber shielded high-speed one at that end. But yeah, obviously a lot quieter than it used to be. So that is pretty good. Haven't put the sensor back on, but I've got to pop that sensor on and put the brushes on here and the brush box cover and also the plastic cover for the wires. But that is pretty much ready to go. So I am done for the day, and that is ready to finish off and to get that control box back on, get this stack built and put this back in. I've also got to do the steering rack on this car, but that's quite accessible now that the engine bay is empty. So I will get that done as well, and yeah, we'll get this car back together. Right, I'll catch you later.